G'day, I'm Dr. Kev and I'm here with Jon Grove. And what are we going to talk about today, John?
We're going to talk about billet.
G'day, welcome to Car Design Workshop. Much earlier in the channel, we put together a video looking at design processes and how we go about developing products. And John here, you've been running your own company. What's your company name?
Jon Grove Engines.
Yeah, named after himself. And John's been developing a whole heap of products, and one of them that I was really excited to see the development over really a couple of years now.
It has been a couple of years, yeah.
Yeah, it was the electronic throttle that you've been working on. So what I thought we would do in this video is do a bit of a reverse and show you the final product and how we got there step by step through the design process, so working backwards. How does that sound?
Sounds good to me.
Okay, so first up, what's the product?
So the DC motor was something that I wanted to generate, one for electronic throttle use, but I also wanted to start looking at things like variable trumpets. So can I design a product that can do multiple things? The DC motor was created and the idea started from there, and it was, all right, let's look at my history and what I've done and see if I can, come up with something myself. It's been a few years and a lot of testing and development, but I've got something that I'm really close to putting to market, and we've got stuff out there getting real world testing. We'll go through the steps on how I got there.
Yeah, that's fantastic. For those of you that didn't catch the interview we did with John earlier, that history includes championships in V8 supercars and NASCAR. So a lot of time spent with engines. So you really know what you're doing with these sorts of products. So what is it that's pretty unique about the product that you put together?
The packaging was a big one. You know, there's a number out there that well, they're on the bigger side. We'll just put it bluntly.
And so you're from racing, and in racing,
packaging, make it smaller, make it lighter, whatever we can. So it was, coming up with a compromise between how can I make something as small as possible without going crazy on the cost.
There's one hooked up here, but I mean, this is incredible. I mean, this one hasn't got the sensor on it.
Not yet, no.
But it's just tiny, and I think the amount of development and the cost of something like this is just huge. And I mean, just holding this, you feel the quality of this product, and as an engineer, you just see the time.
Yeah,
you would have spent a lot of time on this,
and it can be hard to justify, but it's a lot of design iterations. Running into problems, how do we fix that? Running into another problem, how do we fix that? How do we make it better? And now we're at the point of track testing, and we've got them in cars, and we're seeing what's happening once they're actually working, because I don't want issues. They're unavoidable. They do come up from time to time, but I want to minimize them as much as possible and deliver as best product as I can.
So is there any difference in how this product is installed versus other electronic throttles or this sort of motors?
One of the big things with this is it's got a fair bit more torque than other manufacturers. So the reason we did that was so it could be used for things other than electronic throttles.
Let's get this right. You've built an electronic throttle with a lot of torque to put on your motor that produces a lot of torque.
Yeah. So as I said, I've been trying to call it a DC motor more because I don't want it just to be labeled as that. As I said, if you want to do variable trumpets, we're looking at linkage systems. Yeah, we want a bit more power there so it can do those kind of capabilities. So, we've got something in the works for a Coyote, hopefully. If that project kind of takes off, we'd like to do something there. We've got some people, and it might sound weird, but with mechanical injection, there's a crossover with a mechanical fuel pump and a barrel valve that, hey, look, if we could put a bit of control on it, it might actually be a benefit. So those are the kinds of things where you just want to open up people's capabilities.
So when I've been calling an electronic throttle, you're just like, oh, no. It's a bit more than that.
Yeah, and that's the goal. But it is easy to put it straight in that category. It's probably going to be the main use of it, but if you can think of something else that we can use it for, then by all means get a hold of us and we'll see what we can come up with.
And before we were shooting, you mentioned it's got something like a 40-to-1 reduction in the gearbox. It's got a planetary gearbox.
Yeah, it's got a fair bit of torque going on. I'm really happy with that. Obviously, there's certain things we need to keep an eye on. It can create a lot of torque with more amps, but then you have to worry about heat. So we do work on making sure that the throttle systems are within a certain amount of load for safety reasons.
Now, some of the solutions out there already, they're ones that are based off electronic electronic throttles that they often run plastic gears. I'm assuming you haven't gone plastic gears in
No
this?
plastic gears in there. We have really pushed for the reliability. Everything's metal on the inside. I think I've got a pretty nice way of isolating the body, so there's actually a couple of levels of O-rings mounted with shoulder bolts that allow the DC motor to be solidly mounted, but also isolated from the mount. It's very stiff in terms of it's not going anywhere, but it does take that bit of vibration out, which is always a problem with electronics. And that helps not only the DC motor itself, but the sensor. There's been a fair bit of work trying to get those materials right to get what we want, and we'll keep testing and making sure that's doing everything it's meant to be doing.
And this can be just driven by normal ECUs, or what do you need to drive?
Most of these have been tested on a Motec M150. We'll put those videos up, but there's nothing different from any other electronic throttle if you want to use it for that application.
So you'd be able to use just about any engine management system. I mean, I know you're a Motec fan and a Haltech fan.
Yep.
So it'd be work with those, but a number of other solutions.
Correct. Yeah, if it's capable of running drive-by-wire, then you shouldn't be having any problems.
Now, at this stage, am I right in saying that it hasn't been available for sort of general sale yet, but it's in clients' hands right now? So you've had people that have bought this, that are testing it out. Is that about right?
100%, yeah. So we've got one on a circuit car, we've got one going on a jet boat, we've got one on a drag and drive application. So everything we're trying to basically push to the limits, put them in some pretty extreme environments, and the customers are aware of what they're doing for us, but we want to get those Ks on there and make sure, as I said, everything's doing what it's meant to be doing, and then we'll make it publicly available.
So far, everyone's been pretty happy with it.
So far, feedback's been 100%. Everything's been going really well. So I'm extremely confident, but as I said, I'd like to tick all those boxes.
So I guess that's the final product, and
Yep.
we want to work backwards through that design process. And I guess you're still in the stage of testing, aren't you? You're still looking and doing those sort of final validation tests. What other things did you do in the test program for this?
So we started off with a plastic body. So this was kind of one of the prototypes that we started with, and it was, hey, can we possibly design something that could be run in a plastic body?
So that's quick to testing. You're testing even during the early design phase.
Very, very quick. We got that straight on a bench and put some load to it, and very quickly, because you can wire the motor to go around the wrong way, so you obviously need to check that. But that very first iteration, when that occurred, the plastic body had an issue, and it's like, okay, I can't allow that to happen. So automatically we went away from the plastic body, and we'll go to a metal casing instead.
So you've been doing testing early on in the design process using metal parts. Where have you been using to get the metal parts?
So JLC's been really handy there for prototyping, like getting stuff really quick, getting a design through and getting something to your door. We can see here, like this was the prototype 4150 mount, so we wanted to check, make sure the O-rings were where they were supposed to be, make sure the mount position was where we wanted, make sure the link arm was at the distance that we wanted, and having a product, basically in my hands within about 2 weeks, anodized, ready to go. That was extremely handy. A couple of the test pieces I've got here are metal 3D printed, and again, just get a design done, let's try this out, click send, don't worry about it till it rocks up and you're on to the next thing. So that's been extremely handy.
Well, I think in true transparency, this video is actually being sponsored by JLCCNC. And I didn't actually know that very early in the process you were using them. So I knew you were using them to help with your prototyping of everything. I didn't know that it was straight after the first plastic one, you went straight to them.
Yeah, so we've actually been using them for a little while. So yeah, that's been extremely advantageous on jumping on the website, getting a quote, you know what you're up for, you know what you're doing shipping wise, and then as I said, you're on to the next project while that's being done, and you just wait for it to rock up.
Yeah, I think the JLC reached out to the channel not that long ago, I think about a month ago, and asked if we were interested in having them on board. I couldn't say yes fast enough, mainly because we'd already been using JLC. I mean, you've been using it in your product development.
Yep.
We've used it a couple of times at university and around research, and it really has been pretty good pricing. It's been really hard to match those prices anywhere else that we've found for the CNC stuff, and the turnaround's been excellent.
Yeah, and even on the 3D printed metal parts, I have to admit, the fit and finish has been really excellent.
I've been really impressed. I think when I was first exposed to these sorts of manufacturing services, I guess my worries were, what sort of quality would come back. Whoever you're getting to do the manufacturing, you're putting a fair bit of trust in those products, because the big risk is time. So if something hasn't got the right quality, then it can throw back your whole development cycle a fair bit. And I've been massively impressed. So Yes, we are being sponsored by this, but want to make sure that anything that we're supporting in the channel is stuff that we actually use. So really happy to have JLCCNC on board for this video and hopefully future videos for the channel.
Yeah, we will definitely be continue using them.
We've found JLCCNC to be a trusted CNC machining partner. They offer fast, affordable and high precision custom parts for makers, engineers and businesses. So whether you're prototyping or actually looking to sell these products, JLCCNC helps you to bring your ideas to life, exactly how you've designed them. We'd recommend that you at least take a look at what JLCCNC has to offer, and we've got a link in the description that will allow you to get $123 in coupons that can really make your first go a lot cheaper. So getting back to the video, I'd like to know, for this sort of product development, how long has the testing process occurred over? Like when did you start versus getting the first product in a customer's hand, and how much of that was testing?
So we've been at it for about 2.5 years. Obviously that's kind of been on and off with other projects that's been coming up. With the iteration process, we got one of the motors set up. So we had one on the 4150 and we also ran this dual 4500 setup where we put an oscilloscope on there. We were measuring the amps, we were measuring the rate, we were looking at how much control we could get with the system. So we kind of wanted to put a bunch of variations together with what people might be doing. We've got to look at how much inertia is in the system and can we still control that at the speeds that we're expecting. So even with dual 4500s, we were doing 1000% per second. So we were talking really fast throttle rates and the system's able to stay in control. Definitely through that testing regime and checking things are fitting and how we want to do the isolation system, how we want to do the mounts, how we're going to integrate all that together. It takes time.
So you'd been going on this for about 2.5 years. How long did it take before you were on your first prototype? How long were you designing before you started the testing?
Probably somewhere around 3 to 6 months. Obviously we needed to figure out what amount of torque we wanted to produce, how we were going to do that, suppliers and all those kind of things, and then we have to get all that geometry and make it all work. Figuring out what we're going to do with the wiring, how we're going to keep this thing watertight. There's a lot of little things. As I said, you can look at this thing and it doesn't look that impressive, but there's a lot of small iterations.
It looks impressive to me.
But yeah, just really small changes, just to make it nice. So this one here's got a titanium metal housing over the wirings. While that's not as flash as say the billet end that we also supply, it saves a lot in cost. And for a functional aspect, like this part isn't loaded, it's literally just covering the whole back of the wiring and the back of the motor and then sealing everything.
I find it interesting that the thing you say is not impressive about it is the 3D printed titanium part.
Yeah.
That seems pretty impressive to me.
But yeah, that's something that we want to put forward to the customers. We do want to give options. We understand that maybe compared to some of the other stuff, it is on the expensive side, but we are giving a really high-end product with a lot of testing that we're very confident is.
Yeah, I know from the engineering process myself that often you're working with clients and it's hard to show the value and where the value is. And it's pretty easy to assume when you're looking at a product that it's really just somebody's modeled it up, got it right first time, and you're largely paying for the materials and manufacturing, when in fact it's all of that development work to get the performance. And for a really high-end item, it's not mass produced.
Correct.
These are CNC items, they're smaller numbers, and that testing is the value in the product.
Yeah, the end user doesn't see the development between drawing new materials, getting changes, trying different products, trying different setups. They don't have to worry about any of that, but that's something that you've got to do the job right. The FEA takes time, the modeling takes time, doing all your CAD drawings, even just down to the details of your tolerancing. You get a part rock up and you're going, I'd like to change that. All of a sudden you've got another design iteration, new drawings. They're important steps and you need to do them, and that's the joy of running a business and designing your own products, but it is hard to get that across.
And I think if you spend any time in motorsport and around cars, you do see, well, let's just say some parts of varying quality. So you might see billet parts that actually when you go to run them, you're thinking, no, the work hasn't been done here and it just doesn't do the job. And it can actually be quite disappointing when that engineering process hasn't been followed. So it's great to see it here. Is there anything in that testing process that you found really altered your original design?
I don't think so. I had pretty clear goals with what I wanted to accomplish, and I wanted to stick to that. It's really easy to have a project get off course. Timelines can blow out. It was already a bit longer than I was hoping for. We kind of stuck to this is what we want to accomplish and this is how we're going to do it, and just sticking to that goal. Most of the iterations and changes have been small, just to dial everything in. We haven't had anything major, as I said, and so far with physical testing in vehicles, we haven't had anything go wrong. So we're really happy so far.
That's quite a relief. Sometimes when we're designing parts, we have the exact opposite. But I guess you've been working around engines for quite a while, so you have a little bit more idea of a product like this.
Yeah, so I've been lucky enough with, 888, I got to work on the Sandman where we converted a supercar engine to drive-by-wire, and we did a bit of work in supercars later in life as well, looking at drive-by-wire systems on individual throttles. So I'd been through that design process, I'd done the work, so I knew what worked, what didn't work, how I would want to do it. Realistically, the project didn't start when I started drawing it. It started way before that, going through the pain of figuring it out the first time. So
Yeah, and seeing the other products and seeing what was, like, I guess, the competitor products are.
correct. So, and they do fantastic jobs, there's no doubt, but for the applications that I wanted to apply this for, this is what I thought was best. So this is why I've delivered what I've delivered.
And I think one thing to note is that is a product that hasn't really had any great variations from the conceptual stage, being developed by somebody that really knows these technologies well, has used them in the past, and it's still 2 years of testing before it's in a client's hands. And I think that cost in development, it's really easy to underestimate the amount of time that you're going to spend in that testing phase.
It's not something a customer wants to hear, that you had failures, but that's what testing is for. You can't get everything right the first time, and you've got to go through these processes, as I said, to tick the box and make sure that you're doing the best job you can to eliminate any problems before it goes to market. It would have been really easy to rush this out, a year and a half ago, and just send them out and give them to people, but that's not the right thing to do. And we do that with everything I've got. We've got the Group A manifold there, that's been done for nearly 12 months, and I still haven't put it out on market because I want to do more testing.
And I think with engineering, I like to think with engineering that you're wrong a lot until you're right, and the only way that you know you're right is successful testing.
Correct.
So this is a high-end product, so obviously one where you're not going to make huge numbers of these. How does that influence the choice of manufacturing techniques?
So as I said, we kind of experimented at the start with plastic. We did think that was an option, and testing early on proved that's probably not best.
That wouldn't have been 3D printed plastic though. You probably would have gone to some sort of molded plastic.
Potentially would have gone down there. Obviously the prototypes were 3D printed. It's the fastest way of getting a product and being able to go testing. But as I said, for the situations that may occur, I would prefer not to have that as a potential risk. There's definitely the option of casting. We're probably not going to look at the numbers to make that worth it. And with casting, there would be the casting and then the post-machining. So if you're at that point, maybe the CNC option is the best, and that's what we ended up going down. So we did mix that with the CNC and the 3D printed metal, as I said, to give the best value product versus what it needs to be capable of. And that's performance, cosmetics, reliability, cost. We're trying to optimize all those items, not just concentrate on one, and knowing that we want to use it for multiple applications.
Yeah, and I think that CNC hits a bit of a sweet spot. So I think the 3D printed metal, if you're doing a one-off, it can be absolutely fantastic or really small numbers, but then the CNC starts to come into its own once you have the program, you can hit run, there's another one coming out, hit run, another one. So it's not as quick to produce the same numbers as casting, where you can get your unit cost way down, but it's really convenient to sort of be in that mid-range, isn't it? When you're looking for more than just a small handful, and then you can really take advantage of that programming cost and amortize that over a number of units.
And it definitely gives you a bit of flexibility if you do need some iteration changes. There's no change to the cast. If I want to change this bolt size, or I want to move this, or I want to move that, it is a lot easier with a CNC program.
Yeah, I know quite a while ago I was working with a person developing their own Formula Fords, and they had gone down the route of a cast gearbox housing, had some fundamental errors in it, and they were stuck with it. They had to work around the cast for generations, because you have to get that cost back of all of that, and you can't go back to square one. So there is a problem with casting, is if your design's got any sort of variation that you want to it, every variation means it's a whole new process.
Yeah, I mean, you could be looking up to 100 grand for molds. So it is something you need to take into account, and it's application specific. There's definitely cases, the example being we've done a cast Group A lid. We could have done billet, but for the application, we went down the cast road.
So I think that's where size comes into it as well. So with the Group A sort of manifold thing that you've been working on, which is pretty cool in itself, and maybe a thing for in a future video,
I hope so, yeah.
that starts to get really expensive in if you're machining from billet, because you're dealing with a lot of waste.
Yeah, you're starting with a really big chunk of metal to get rid of most of it. There's definitely nothing wrong with that, but it's about balancing cost, cosmetics, performance, and delivering the best product you can for the customer.
I think something around this size, it's pretty much perfect
Yeah.
for CNC.
100%.
And that looks fantastic.
It does, but I'm biased.
So I guess with Jon Grove Engines, you're not quite a one-man shop at the moment. I mean, I know your wife's involved with the company as well, but your numbers are pretty small. Like it's really you're doing the engineering for all of these products. You don't really have too much of a choice at this stage to do a lot of in-house manufacture. So where do you stand on these sorts of products with how much your design is altered based on whether you're able to bring things in-house or send it outside?
So like all businesses, we rely on other people. You can't do everything yourself. So we need to make sure that we're working with the right companies to deliver the right product to the level that we want and have an understanding on what we're trying to achieve. I definitely focus on the areas where I can have the most input with what I want to, and then we deal with those kind of companies. While we're not manufacturing in-house at the moment for billet parts and stuff like that, that's something potentially down the future, but right now, we're doing a lot of product development, so we're doing a lot of CAD, we're doing a lot of FEA, and that's where my time needs to be more focused. So if I can have companies that were doing some of this initial work on the East Coast, like Scaff Engineering down in Victoria, I know the quality of work that they're doing and I can be comfortable. We're going, hey, this is what we're trying to do, and I get back what I'm hoping for. You need to be very conscious on not focusing on one area. Our business revolves around multiple facets, and you need to make sure you're ticking all those boxes.
It's worth noting here that you haven't got a company that's assembling the whole thing. You're getting individual parts made, and then you're putting it all together.
Correct.
So you have final quality control over the product.
Yeah, correct. We're building these to the highest standard that we can.
Yeah, and I think that's pretty much what we'd expect to see in anything automotive. I mean, no car manufacturer makes every little part of their systems. They're actually putting together major assemblies into things like vehicles and so on. So it's not a different process, but I guess a difficult one to manage. I mean, how do you manage the fact in a product like this where you have multiple suppliers for different parts? How do you just organize all of that side of manufacturing?
It's just a lot of work. I mean, you can't put it down to anything else. So, we've got multiple spreadsheets with what's going on where. Obviously, we run an online accounting software. It's just about being organized and putting the work in. So there's no real way of getting around it. It's not something that you can call AI up and go, hey, I need a bit of a hand with this. You've just got to be doing all the right things and making sure you're staying on top of it. Communication is a really big point of that. So with your suppliers, with your customers, there's always something going on in the world that affects things, and you need to make sure that you're on top of it and everyone's aware of what's going on both ends.
Yeah, and I think if you've been around engineers very much, I think we tend to get accused of being maybe emotionally distant or poor communicators. And I think that's a bit harsh, because I think in the engineering game, you have to be effective communicators. So you have to communicate with suppliers, you end up communicating with customers, and it might not be a part of the design process and product development that we enjoy as much as other parts, but it's really important to do it well.
It's really important. It can make life a lot easier if you've got suppliers on your side and you go, hey, look, I've run into a problem. I need this thing done overnight. And if they're on your side, you've got the potential of getting you out of trouble. You realize that you can't do this by yourself. And it doesn't matter on what level, as you said, all the way up to the OEMs, you are relying on other people.
Building those relationships, it takes time. You have to meet people and do all of that. And I think once you pass that sort of design stage, and as soon as you're heading into manufacture, that's when you're really reaching out to people. You have to be there. I mean, I guess you're reaching out during the design process.
Yeah.
But once you hit manufacturing, that's it. Other people have to be involved.
Correct. I mean, I always find the worst bit is quoting, because it's that thing of I need to go to multiple suppliers and figure out who's doing what, looking at the cost, looking at the supply time, look at the quality, and you always feel a little bit, oh, I'm asking you to do all this work and you might not get the job. But that's life, you know?
Well, I guess you get the other end of that. I mean, we both worked as consultant engineers. I mean, you're working as a consultant engineer now. I'm well past that. The quoting is really awkward when you're on the other side, when you're creating the quotes, and you have to, in your business, do a lot of work where you're not entirely sure that you're going to see any return for it.
Yeah. And that's difficult, but as I said, if you want to run your own business, these are the cards you got to play.
The stage before manufacturing is that detailed design phase. And this is the phase I think as engineers we really love.
Yeah.
Because that's dream phase. Like in the design phase, everything works. everything passes the
Everything
test.
fits.
Everything fits. Mainly because we ignore when they don't fit.
Yeah.
So I guess nuts and bolts. What sort of CAD software did you use?
So I've been using SolidWorks pretty much my entire professional career. It is what I know as well. So most people are comfortable with what they know, and it gives me a lot of capabilities when you start adding in, FEA, CFD. It allows me to do a whole lot more than just draw. When you start putting things like a PDM in there, and that can help eliminate some issues. There's definitely a lot of time spent at the computer drawing lines and making everything fit. We're going to the point of making sure we've got all the fasteners in there, our bill of materials are correct. We're getting to the point of, hey, this is the bolt list for this part. This is the O-ring kit for this part, and we've got all that separated so stuff can be ordered, as a kit. There is a lot of work on that side that also doesn't get seen. There's hours and hours on making sure the paperwork and the information is stored correctly for future and past.
You're a fairly handy machinist and fabricator yourself, and I guess when you're making your own parts for your own projects, you don't necessarily need to model everything 100%, but for a product like this, every last detail.
Correct. And if we are making small iterations through time, we need to make sure we know what customers got what. You can't go too far. I mean, you can obviously with time, but realistically, you can't have too much detail.
How much of the later stages, such as the manufacturing and the testing that you've got to do, how much of that reaches back into the detailed design? How much of it are you considering before you have that first test of a prototype?
You've got to try and think of every situation. We're not just putting these things in cars, we're putting them in boats. Then you're looking at a whole different environment that they've got to work in. So you want to go through all of that in your head while you're doing in the design process, because it's a lot easier to do it then than after. And that's the hard bit, when you're doing FEA and calculating loads and stuff like that. It is trying to think of every situation that this part might go through and doing the work then. It's really easy to go, hey, I tested this and I tested that, we're good to go. And then someone goes and sticks it in a situation that you didn't think of, and you go, oh, in this application, it's going to see this. So that's where experience comes into it, knowing what you're going to be doing with it.
Before working on your own company, you were doing some product development for mainly the mining industry after you were working in motorsport. And I guess each project, you have to very carefully allocate time as to how much analysis you do in each stage, because at that detailed design, if it saves you time later on, that's a real bonus. But if it just costs you time and you don't learn anything from it, it just adds cost to the process.
Yeah, so in that kind of situation, you're trying to do basically a little bit of learning with every project and then carry that through. You can take that situation and go, we can apply this to the next one and then the next one. And you start getting a bit of a boundary box, and you'll find you're doing less and less of the big stuff, and then you start getting into more detail and then more detail, and then how do we get more efficient? And then, hey, where can we start saving costs? Where can we reduce our material usage? Where can we reduce our welding? So it should never stop. If you're doing a really good product, then you should always be going through it. Or you might be one of these companies that has been making the same thing for 100 years and you never have to change anything. I mean, that sounds great to me, but I also like the challenge of developing products. So
I know, I guess probably would have been the same for you, but when I was a junior engineer, I think the thing that amazed me about people that had been doing it for a while wasn't that they were doing anything considerably more impressive. They were just going into more detail. So the senior engineers just always seemed to be one step ahead and thinking about another aspect of the project that you weren't really thinking about before you had that experience. I was just massively impressed by senior engineers putting that detail work in, and I guess our journey as engineers as we develop is to learn the importance of that detail.
100%. I mean, you just don't see they've been there and done that. Time is the only way to get it.
So if you are a senior engineer, full respect, and if you're a junior engineer or somebody just learning this stuff,
Keep at it, you'll be right.
Yeah, you'll get there. You'll get there. A lot of hard work. Before we're doing the detailed design and getting down to every last nut, every last bolt, every last detail, you are dealing with concepts. Now, earlier on, you mentioned that you pretty much were keeping the same concept. You had a fairly decent idea of what you were going to do.
Yep.
How long was that conceptual design process for this? Was that more, I guess, thinking about it a lot as you, and just it's all mental, or did you sort of formalize any of that conceptual design process?
I kind of took the approach on I want to fail fast. I had something in my head, let's get it into CAD and let's get something printed as soon as possible. I have to say, I think the concept time allocated to it was actually pretty short, and I think that just came with the experience and knowing what I wanted to achieve like really clearly, compared to say like the Group A manifold or some of the other projects where I was just starting afresh and it was literally just, let's take this idea and see what we can do with it. The DC motor was something that had been in my head for at least a few years. It really helped narrow down that concept time, which it can be really draining, and it can be frustrating when you're just making these small changes and you're going, oh, I didn't think of this. And then you've got to go back and your model explodes and you start again. And that's always a really tough decision on when you're looking at a fairly serious CAD model and you go, I really need to start this again, because it's getting a bit patchy or too many iterations going on, and they can be really time consuming. The biggest thing we all want to achieve is you want that thing in your hand. Yeah. So you want to get it off the screen and start working with it.
I guess that's why I asked how much of it was formalized, because so much of your conceptual design would have been occurring just you thinking about the product for the years beforehand, before starting that. And that's not really captured as a cost, is it?
No, and it can depend on the person as well. I tend to be quite visual, so it was one of those things where maybe I should have done more of that, but I just wanted to get the thing on the screen and start looking at it. And then that's where 3D printing with plastics and how cheap and readily available it is to have one of those in your workshop and just get something out and print it, get it in your hand, has really changed how quickly you can go from concept to, as I said, holding a physical part.
Things like the technologies like 3D printing, they start to blur the lines between what is a conceptual design and the detailed design.
Very much so.
Because you're not first manufacturing or first printing something that you think is completely sorted out. You're heading to that manufacturing phase really early on, just to get a sense of, is this what I think it is in my head?
Yeah.
So I actually think the 3D printers in that conceptual phase are really valuable.
They are. They can also be invaluable when you get impatient. So I 3D printed an entire Coyote top and then realized I had forgotten the fuel rail mounts. So, just in my haste to, I've got this thing in my head, I can't wait to see it. Oh, now I've got to do this again because I missed a step. And so it can be a negative just if you just get a bit excited, I guess. So
you said that the concept was pretty well sorted straight from the start. What were the things that you felt right from word go that were non-negotiables?
Packaging wise, I knew what I wanted to accomplish. So the layout of the body was really important, and the sensor on the end of the engine was a non-negotiable. On things like the Motec, we are able to run a closed loop system where we have a sensor on the motor and a sensor on the throttle body, and they are constantly in feedback with each other. And that is pretty much something I outright refuse to not do. It is possible to run these systems without that, but from a safety point of view, that for me, it wasn't an option. It had to have a sensor on the end of it.
So you had more of an idea of this is going to be in a control situation. You wanted it to be a professional product that you would normally use in something like racing, where you want to know exactly what it's doing at every moment.
Correct.
And you wanted it small.
Yes. Yeah, 100%. The window that I was looking at, as I said, it was from kind of your average Joe just getting into racing, doing a bit of this, doing a bit of that, to all-out F1, LMP, however far you want to go with it, somewhere in the middle.
As soon as you're in that sort of concept, and you're saying it's going to be small, then that leads you to things like planetary gearboxes, like multi-stage planetary gearboxes, rather than other solutions. That concept, I guess, drives quite a lot of your detailed design in the later stage.
100%, because once you've come up with, you're working with the manufacturer on the motor and the gearbox, everything works around from that. That really locks you in once you've kind of got that sorted.
As you start to reach this point, I guess, in the detailed design where some of the major decisions are made and the rest just starts falling into place.
Very much so. Once you've got the key goals that you want to achieve, like the isolation mount, I want the sensor on the end, you go, I just got to figure out how to make that work, but this is what's happening. That side of things can be very fluid with how they happen.
Yeah, I always loved that stage of design where things seem to flow and and everything just is coming easy, but there's usually so much work before that.
Yeah.
And so making the right decisions conceptually and in specification and everything gets you to the point where you can have that flow in design.
Yeah, and then you usually get to about 95%. It's the last 5% that you got to get through.
Yeah, that's the extra year and a half in
Yeah,
testing.
100%.
So even before we hit the concept stage in design, and I think we've already started to hint at it, you start with a specification as to what this product is going to be. What are some of the key things that you would have pulled out from the specification? Were there particular goals in mind? I guess was speed a goal or torque a goal? Or
They both were definitely up there. We know from experience with working on race cars what kind of throttle weights I needed to accomplish. Knowing what gearboxes were available, how we're going to hit that, what torque's going to be required to do those kind of things. Understanding what kind of loads it might see, you're working back from that, and they're kind of setting those points for what you need to accomplish, and that narrows your field of view down for products and stuff like that. For me, as I said, not being very strong electrically when I started this, there was a little bit of learning as well that I had to go through with what's going to be best for the application. Even things like what's the best way of wiring this to be reliable as possible. And in those situations, it's best to go and talk to people that have experience. It's a lot faster to go and have those conversations than find out the hard way what worked and what didn't work.
No, so I guess in that specification stage, when you're trying to figure out what those numbers would be, what the sizes of things would be, and before you're going into that design phase, you're bringing in other sources of information to help you define that.
We have to admit to ourselves that we can't know everything. So you need to...
I'm not there yet.
you need to know when to put your ego aside and go...
Again, I'm not there yet.
Well, I might be saying these all specifically. You need to know when you can do the best job and when it's best to get someone else in. So my priority, as I've kind of been pointing to the whole time, is how do I supply the best product I can, and where I'm not the best person, I make sure they're involved. So
yeah, and I guess the fact that you didn't have to spend too much time in the conceptual phase, and even the detailed design phase, you're basically saying from start of this project to the first testing was really only 6 months, which may sound like a lot of time, but for a product that you're intending to sell is absolutely not a lot of time to get through those phases. That really comes down to a very clear specification of what you wanted for this product.
As I said right at the start, that's where these projects can get out of hand really quickly if you let that vary.
Sticking to that specification, I mean, you don't always get that luxury. I mean, sometimes you have to come back and change what your specification is, or as you're learning things, you realize, oh, this isn't possible. But I guess a successful sort of product development like this, which still takes a long time, if the specification is clear at the start, you have a fair chance of success at the end.
I think so. So I think the doing things that way works really well for me, and I'm probably going to stick at it.
Yeah, and I guess that's where, whenever we're looking at the design process, it just gets more expensive to make changes the later you have to make those changes.
Yeah. So that's where I like the let's fail fast, and testing in data is king. So
yeah, and I guess 6 months in, if the first test was an absolute disaster, that's a really good rethink time rather than 2.5 years down the track.
Correct. Yeah, I might have gone a long way down the plastic road before going, yeah, this was wrong. So yeah, I like to get that information as soon as I can.
Yeah, and I guess the first stage of any project is that market research phase. Is just knowing, what is this product going to be, who's it competing against, who's going to use it, I guess all of the regulations and things around this. What were some of the key things that you were doing before you even started to go down the path of making a product? What did you think in terms of the market, and what was the niche or the hole that you saw that your product could fill?
So one thing that's really coming on strong, like most, is as people catch up with technology. So drive-by-wire isn't anything new, but in racing, there were certain categories that were using it, and there was a lot that were still sticking to the cable. After doing a couple of projects with it, when you start seeing the benefits that it gives you, it's like, okay, well, we want to jump on this while everyone's getting up to speed. So we could definitely see a bit of a window there. The fact that I'm doing my own intake manifolds and I want that freedom to be able to do it the way that I want to do it. So by doing the DC motor myself, I can integrate it into my designs and I can accomplish what I want to accomplish the way I want to accomplish it. That gave me a lot of confidence in taking that next step with some of the projects where, hey, if we do drive-by-wire, all this is possible. And I have to say probably a little bit of it was just I needed to get the idea out of my head.
Okay, so I'm not much of a drag racer or that sort of thing. I'm not an engine guy. If I've got engine questions, I'm normally calling you up at some ungodly hour of the day. I see that you've got the product here on a couple of heads, and to me, they look like sort of carburetors. But they're not, are they?
No. So these intake manifolds, we've got the Holley 4150 throttle body. So while this does look like an original carburetor, it's actually got injectors on the inside. So I know some people are still very much on the, carburetors make more power, but I do like my EFI, and as I said, the drive-by-wire gives me a lot of advantages. And then we've got the tunnel ram with the twin 4500s. Again, what we're looking at is control. Yeah. So we've converted this from carburetors to EFI as well as the drive-by-wire, and there's going to be a lot of freedom that this is going to give us, and we're really looking forward to the testing on that.
So you've still got all of that, I guess, that classic look and feel and so on, but it's really advanced.
But with all the benefits, yeah. So there's definitely nothing wrong with the carburetor. I'm not saying that, but yeah, in terms of what we're going to now be able to do with this, it's on a whole nother level. So we're really looking forward to that, and I think it's where everyone else is going. So we're, hopefully we've picked the right path, and all this follows suit.
So right at the start, when we were talking about some of the clients that are running these motors now and doing some of these final stages of testing for the product, you said, was it a jet boat?
Mm-hmm.
It's on a drag car and a circuit car. So I guess this sort of product is bringing that technology to racing, but not even just cars, just anything that's got this sort of motor on it.
Yeah, when people are looking to idle control, or they're looking to do launches based on throttle position instead of with an ignition cart, maybe they want auto blitz on down changes. They're all these things that we can accomplish when you add drive-by-wire. With a kit like this, if you're running a carburetor, you can put this on a carburetor if you want to. We've put one of these on a early 2000s Morrison manifold that was well and truly, capable back in the day. But it allowed us to convert that car to a full sequential gearbox with auto blips and idle control, and we can limit the throttle during pit lane. If you really want to go further, you can do a bit of throttle-based traction control. The sky's the limit,
So when you were doing your initial sort of market research or just seeing what was out there, did you imagine all of those applications right at the start? Or you got to level with me. Did you imagine that one of your first sort of 3 throttles would be on a jet boat?
No, definitely not the jet boat. I didn't see that one coming, and not carbureted. So that one was really surprising, but we're really excited to see how that goes and how far they can push it. As I said, I was more focused on what I was doing and what I could accomplish, and now that we're seeing other people are seeing what's possible, I said we're going to make it publicly available and allow other people to take their ideas and see what they can do with them. We're at the point now where we've got a supercharger intake manifold, bug catcher or whatever we'd like to call it. Imagine having something where you can control the rate of that throttle, or you can put your foot to the floor and only get 5% of throttle blade movement. Stuff like that, it's kind of, just what can I do with it, and just see what you can. I'm still going to keep pushing it as a DC motor. I don't want it to just be used as a throttle. I said, I'm really excited about the Coyote manifold with the variable trumpets, and we'll just see what anyone else can think of.
I guess the fear for all product developers is that you'll get 2-3 years down the track and somebody else is going to come out with the exact product that you've got. How confident do you need to be that that there is a place in the market for this product, for you to be, I guess, willing to put that huge amount of time in product development?
I guess I need people to be, when they figure out who I am and what I'm doing to make this as good as I can, that it gives them the faith in my product. There's definitely no guarantees in life, and items are very easily copied, especially these days, but it's putting their faith in me as well as the product that they're getting from me. After that, you just have to go with the punches.
That's also an aspect of engineering, is that product development, it takes time. It takes money, it takes time. Sometimes time is money, and there's a risk associated with it. So I think anytime somebody has gone through that product development cycle, you reach the end, and if everything's still good, if the market is still good, if there's still applications of it, then that can pay off. But you have to take the risk. And I guess you can't know everything at that start. So you try and do as best you can to be pretty sure that even if there is a competitor that comes on, that you've still got a good product, that you've still got something that compete against with whatever comes in the next 3 years. Yeah. So is there anything that, I guess this is towards the end now, I guess you're straight on the new products though.
Yeah, we're constantly developing multiple products at one time. We've got these being tested currently. We're about to hit the engine dyno with a couple of new intake manifolds and setups. A couple of those will feature drive, the DC motor. We've got all kinds of products going on the website. We're kind of not stopping. If I've got these ideas and I think they're good ones, then we're just going to allow people access to them.
Now, I've got to strongly recommend, I mean, John's my friend. I'd recommend this anyway, but even just as an engineer, if you're into cars, if you're into engines, you really should check out some of the stuff that Jon has been doing. You share a lot of it on your socials. I know I'm old school, like I guess old school in terms of computer terms. I go to Facebook, I don't do the Instagram and stuff like that. That's for you young fellas. But I'm amazed at what I see there, the development work that you're doing, and the fact that you're sharing that and sharing your ideas. If you're into that, check it out, Jon Grove Engines. We'll leave links in the description of the video, so feel free to jump on, maybe comment on some of the stuff that Jon posts. But I think if you're into engines and product development, you'd be really impressed with what you see. Thanks for your time.
Thank you.